Hi everyone, welcome back to another Planetarium live stream. We've got a fun one for you today as we're going to start exploring our solar system. For anyone who is new here, hi, welcome. My name is Jessica. I am the director of the Planetarium, so I have the totally awesome job of running a planetarium, which is fantastic. So give me just a second to get our virtual spaceship ready and we will hop on up into the universe. As usual, if you have any questions, put them down in the comments. I will be checking those periodically and we'll try and get to them. And I will also take some time at the end to answer any questions that I didn't get to during the course of our event. And at the end, I also want to tell you about a couple of fun at-home activities that you can do that will help explore kind of the sizes of the planets and the distance between the planets, because it can kind of be hard to understand exactly how big space is and how big the planets are, especially compared to each other. So I am going to switch on over to our spaceship now. And so we are officially in space. Welcome, welcome. I will say this is a new program that I am using. This is not the same one that we typically use in our planetarium. And since it is new to me, there may be a few bumps along the way, but I think I've got the handle of it. So we're starting off kind of looking down on our solar system. We have the sun at the center, and then we can see these circles, which are the orbits of the planets in our solar system. And what's really cool is when we look at these orbits, they all are almost perfectly circular. But then if we look kind of edge on, we can see that all of the planets lie in a thin plane. Our solar system is like a frisbee or a pancake, with everything sitting in the same plane, the same kind of pancake. And we think that comes from how our solar system formed. We think that it formed from a disk or a frisbee of gas that all of the planets then formed inside. So to start our journey, we are going to head to the center of our solar system, where our sun lies. Now, our sun is a star, just like the stars that we see up at night. Of course, the difference is it's a lot closer to us, and so it looks a lot bigger and brighter than the other stars that we see in the sky. But since it is a star, that means it is a big ball of hot, glowing gas. Now, the kind of texture you're seeing is because this big ball of hot gas is churning, kind of like a pot of boiling water or a lava lamp, where we have hot stuff kind of rising up to the surface and cooler stuff sinking down, and it makes this almost like oatmeal-like texture. You can see the kind of churning all over the surface. All right. Well, let's make our way to our first planet. Closest to the sun is the planet Mercury. And we're going to fly on over. And we have reached Mercury. So Mercury is the smallest of the planets. It's about a third the size of our Earth. And it should look kind of like another object that's pretty familiar to you. It looks a lot like our moon. And that's because Mercury and the moon are very similar objects. They're both these big balls of rock floating around in space. And we see that they are covered in these marks, which are craters. And so this comes from years and years and years of being hit over and over and over again by debris, by junk in space, little pieces of rock and comet and asteroid that just hit the surface. And since Mercury doesn't have any running water, any wind, any type of erosion or volcanoes, there's nothing to erase the craters once they form. And so they just keep piling up. And because we're seeing pretty much the history of how Mercury has been hit for the entire about 4.5 billion years the solar system has existed, we see it absolutely covered in these craters. Now, since Mercury is the closest planet to the Sun, it of course is going to be very hot. Temperatures on Mercury can get up to almost 700 degrees Fahrenheit, which is of course super, super hot, but that's only in the daytime. At night, it gets extremely cold, dropping down to almost negative 200 degrees Fahrenheit. And that's because Mercury doesn't have an atmosphere. So an atmosphere acts like a big thick blanket. It traps heat and keeps a planet warmer than it would be. And so without that blanket, once the side of Mercury turns away from the sun and it's nighttime, it's not getting the warmth from the sun, it cools off very quickly, dropping in temperature drastically. And so we see Mercury is kind of a world of extremes. We have the really hot daytime and then the really cold nighttime. All right, let's head on to our next planet. And as we fly over, we will see Venus. So this is actually not a typical view of Venus because Venus is covered in thick clouds. And so normally we can't see down to the surface because those clouds block our view. But what we're seeing here are images from satellites and spacecraft that have orbited around Venus and taken pictures with cameras that could peer through those clouds and actually show us what the surface looks like. Now, for a long time, it was thought that Venus was a lot like our Earth because Venus is about the same size as the Earth. We saw that it had clouds like the Earth has. And so a lot of people kind of speculated that Venus might be Earth's twin. It might be a lot like it. But they couldn't know for sure because they couldn't see through those clouds. But once we had radar imaging, which allows us to peer through those clouds, we saw that the surface is a pretty much desolate desert. Because Venus, it turns out, is the hottest planet in the solar system, even hotter than the closest planet, Mercury. And that comes back to that really thick atmosphere. It acts like a thick blanket and it traps so much heat that temperatures on Venus reach almost 900 degrees Fahrenheit. It's absurd how hot the surface of Venus is. So hot that it would melt metal, which is why we don't send a lot of things to land on Venus, although we have landed a few spacecraft. They lasted anywhere from about 45 minutes to almost 2 hours before they were destroyed by the extreme heat. But they gave us some of our only views of the close-up of Venus's surface in real imaging, not radar imaging. So yeah, that is the planet Venus. So we'll head on now to our next planet, the third planet from the Sun. And that is, of course, our home of the planet Earth. So it's the planet we know the best. Earth, of course, looks quite a bit different than the other planets we've seen so far, than Mercury or Venus. And that's for a couple of reasons. Earth is the only planet in our solar system, the only world in our solar system that is covered in liquid water. About 70% of the Earth's surface is covered in liquid water. And of course, we're the only world that we know of that has life on it, right? We have plants and animals and humans, and we're the only world that we know of so far that has that. And so that makes us pretty special. Although we are searching for other places, and we have a couple of good possibilities for places that there could be life elsewhere, and we'll get to those in a little bit. Now, Earth has a companion, our moon, which we know and love. And so our moon is about a fourth the size of Earth, which is actually pretty big for a moon. Most moons in our solar system are much, much, much smaller than the planets they orbit around. And so it was kind of strange to find that our moon is so big. And we think it's so big because of how it formed. We think that at the beginning of the solar system, something about the size of Mars crashed into the Earth and blasted out a bunch of rock. And that rock collected around the Earth and formed into our moon. And so we think that that's what attributed to its bigger size, is because of all of that material from that big impact that hit the Earth. Now, this is a side of the moon that we don't typically see. This is the side of the moon that's always facing away from us. So it's the far side. You will see here that it is getting daylight, though. So it's not necessarily always the dark side of the moon. I blame Pink Floyd for this misconception, but there is actually no dark side of the moon, or at least no permanent dark side. So I am going to speed us up in time a little bit so that we can, oops, I went a little bit too far there, so that we can see the side that we know. So this is the side of the moon we're more familiar with, the side that always faces us. And again, we see it looks very similar to Mercury. We see it's covered in these craters, and that's for the same reasons, because the moon doesn't have running water or an atmosphere, so it doesn't have wind, so it doesn't have any processes to erase these craters, and so they just stick around. We will see, though, that unlike Mercury, the moon has some dark patches. And these dark patches are known as the lunar maria, which is Latin for sea, a body of water. It's not water. That actually comes from before we had telescopes. When people looked up at the moon and saw these dark patches, they thought it looked like bodies of water, and so that's what they called them. But then we got telescopes, and we could look nice and close, and we see craters and cracks and ridges, and so that tells us it's rock. It's not a liquid, but the name stuck since we've been calling it that for so long, so we still call them the lunar maria, or the seas on the moon. But what these dark patches are actually ancient lava flows. Back when the moon was younger, it was still pretty hot inside, and so there was liquid or molten rock underneath the surface. And every so often, when it got hit by something really big that could crack open the surface, that would allow that molten rock to make its way to the surface and spread out, covering parts of the moon. And as it cooled and hardened, it formed these dark maria. But that's also why we don't see as many craters in these dark regions, because that lava repaved the surface. It filled in all those craters. It's just like filling in potholes on the road, which is something especially us here in Duluth know a lot about. It did the same thing, and so it just filled in those craters. All right, let's make our way to our next planet, which is the red planet, the planet Mars. Now, Mars is known as the red planet for pretty good reasons, because, well, it's red. And that red color comes from rust that is all over the surface. So Mars is about half the size of Earth. A lot of people don't realize that it is a good bit smaller than our Earth is. And there are a couple of really cool things to see on Mars, although right now they are not in the daytime, and so I'm going to have to speed up time just a little bit, or maybe a little bit more than I meant to. Again, new program, I'm still learning it. Here we go. So let's go just a little bit forward. All right. So right up here, kind of in the top left of Mars right now, trying to move it more center, we see this big thing, which is actually a volcano. This is Olympus Mons. It is the largest volcano, not just on Mars, but in the solar system. This volcano is so big, if you were to set it on the planet Earth, it would cover the entire state of Arizona. And it's about 3 times taller than Mount Everest. So an absolutely huge volcano. It is not active anymore, but it used to be very, very active, which is how it built up to be such a big volcano. Now kind of down and to the right, we see some more volcanoes. Mars has quite a few of them covering its surface. But then right next to those, we see this big gash. This is a canyon stretching across Mars. This is known as Valles Marineris, and it's similar to our Grand Canyon, but actually grander, because this canyon would stretch across the entire United States. And it gets, I believe, 4 times deeper than the Grand Canyon does in some places. So just another big feature on Mars. Now, Mars does have 2 moons. They are known as Phobos and Deimos, and we can see their little paths there. Unfortunately, this program doesn't have a good view of the moons like our program does back in the planetarium. But if you want to kind of picture what they look like, I lovingly call them lumpy space potatoes, because they're really just lumpy chunks of rock. Because we think that they are actually asteroids that got captured by Mars. And that makes sense. Mars is right beside the asteroid belt. And so it's not that hard to imagine that a couple of these little chunks of rock just got a little bit too close, and Mars's gravity grabbed onto them, and they became moons of Mars. All right, so that is the last of our inner rocky planets. And so now we're going to make our way out to the outer planets. And our next planet up is the planet Jupiter, the king of the solar system. Jupiter is the largest planet in our solar system. It is about 10 times the size of Earth. We can see it's marked by these really pretty bands of clouds. And there's also lots of swirls in there as these clouds are kind of mixing together. And then Jupiter's probably most famous feature is this big red spot here, known as the Great Red Spot, because astronomers are not always clever when they come up with names. And this is actually a hurricane, but not a hurricane like we would have seen, because this hurricane is about 3 times the size of the Earth. And it's been going on for over 350 years. Basically, as long as we've been looking at Jupiter through a telescope, we have seen this storm. And we don't know why it's lasted for so long. It's one of the mysteries of Jupiter we're still trying to figure out. So Jupiter has quite a lot of moons. We're not seeing all of them here. Jupiter actually has 79 moons. Most of these are lumpy space potatoes, like Mars's moons. But there are a couple that are really interesting that I want to show you. And so we're going to start off with Io. Now, Io is one of the 4 largest moons around Jupiter. These 4 moons are known as the Galilean moons because the astronomer Galileo is the one who first discovered them. And so Io is actually the closest of the Galilean moons to Jupiter. And we like to call it the pizza moon because it kind of looks like a pizza, right? We got that yellow cheese, the red sauce, black specks, which could be whatever you want. I say sausage. One of my students says olives. I think he's crazy because olives don't belong on a pizza. But all of these dark spots that we're seeing here are actually volcanoes. Io has over 150 active volcanoes, more than any other world in our solar system, even the Earth. And that's strange, because Io is actually smaller than our moon. And our moon doesn't have any volcanoes, let alone hundreds of active volcanoes. But it turns out that Io has so many volcanoes because it's caught in a tug of war between Jupiter on one side of it, pulling it towards Jupiter, and the other moons on the other side, pulling it the other way. And as it gets pulled back and forth, the rocks rub together. And just like on a cold day when you rub your hands together, these rocks get hot from friction. And that heats up the inside of Io and creates all of these active volcanoes. And so it's that tug of war between Jupiter and the other moons that is causing Io to be so active. Now, that yellow color actually comes from sulfur, which is all over the surface. So if we want to stick with the moon analogy, or the pizza analogy, this would, I guess, be a rotten egg pizza, which definitely does not sound appetizing. Now, the other of the Galilean moons that I want to show you is Europa. So if Io is kind of the land of volcanoes, Europa is the land of ice. Because covering the surface of Europa is a shell of frozen water ice. And we can see these cracks around the ice, and that's because Europa is caught in a similar tug of war as Io. Now, since it's a little bit further away from Jupiter, that tug of war isn't as extreme, but it is enough to heat up the inside, and that melts some of the ice just below the surface. And so we think underneath this icy crust lies an ocean of liquid water. And not just kind of a small ocean. We actually estimate that there is twice as much liquid water on Europa as we have on the entire Earth. So this would be a huge ocean of liquid water. And astronomers and scientists are really eager to explore that because one of the things that we believe life needs, is essential to life developing, is liquid water. And so when we see a world that has a lot of it, we think the potential for life to have developed there could be pretty high. And so Europa is one of the places that we are searching to see if there is life elsewhere other than Earth. And there are actually new missions that are being planned to land on Europa and either drill through that icy crust or melt their way through and then explore that ocean below. But there is a lot that we have to consider before we do this, not just the difficulty of getting to Europa and melting or drilling through that ice, but we want to make sure that anything we send is completely sterile, because we don't want any Earth life to invade this world, and especially we don't want it to interfere if there is any other sort of life there. And so we have to be really, really careful whenever we decide to move forward with this and go explore Europa. All right. Well, I think it's time to move on to our next planet. After Jupiter comes the planet Saturn. Well, Saturn is most known for its beautiful rings, but it's actually not the only planet to have rings. Jupiter, Saturn, Uranus, and Neptune all have rings. It's just that Saturn's are the biggest and the brightest, and so they're the easiest to be seen with a telescope here on Earth. So they're the first ones discovered, and they're the easiest for us to still see. In fact, if you look at Saturn through even a small telescope, you can see the rings. It's actually a really incredible sight, and I highly encourage, if you haven't looked at Saturn through a telescope, you should, because it's amazing. Now, these rings of Saturn are not solid, like they kind of look like here. They're actually hundreds of thousands of pieces of ice that are all moving around Saturn in this ring type shape. And we're not quite sure where all of this material that is forming the rings has come from. It's likely that some of this is some debris that's been knocked off of some of Saturn's moons, but most likely what we're seeing here is actually the remnants of a comet, an icy comet, that got just a little bit too close to Saturn, and Saturn's gravity ripped it apart. And now all of the kind of shredded pieces of comet are orbiting around Saturn in this ring. So Saturn also has quite a few moons. It actually is the reigning champion of moons, having 82. So it is the most of any planet. And that number has recently changed. Just last year, we had discovered 20 new moons, which is why that number is now up to 82. Now, most of these are like Jupiter. They're lumpy space potatoes of either rock or ice. But there are a couple of larger moons that are really interesting. Let me find them real quick. And so we'll go see the largest moon around Saturn, which is Titan. So Titan is an interesting moon because it is the only moon with a thick atmosphere. But it's not an atmosphere like we know. It's an atmosphere of nitrogen and methane and ammonia and things like that. But what's also really interesting about Titan is it has liquid on its surface. Now, it's not liquid water because it's far too cold for liquid to be, or for water to be liquid on the surface of a world all the way out here. It's actually liquid methane. But there are lakes of it. It rains liquid methane. Titan has a whole precipitation cycle like we have, just with methane instead of water. And that intrigues us because while we know life as we know it depends on liquid water, who's to say a type of life couldn't develop that relies on liquid methane instead? And so this is a world that we're interested in studying to see if life could form in a way that we don't know of. That's not, what we find life as we know it. And there's actually a brand new mission that is going to be going to Titan. It's named Dragonfly, and it's going to be a little helicopter because there's a thick atmosphere, which means we can fly. And so this helicopter is going to fly around and explore the surface of Titan, which is going to be great because with the helicopter, we're going to be able to cover more distance than we could with a rover. So this is going to be a really exciting mission, and I can't wait for it to launch. All right, we have 2 planets left. After Saturn comes the planet with the funny name, planet Uranus. But I have to tell you, this is actually not its original name. When this planet was first discovered, it was named George. Yep, George. So this planet was discovered by the astronomer William Herschel. He was an English astronomer, and he knew that if he wanted to make the King of England happy, he should name the planet after him. And so that's what he did. That's why it was named George. It was named after King George. And the king did like this a lot, and so he gave William Herschel a lot of money for it. But other astronomers who were not English and did not serve the English king were not happy about this. And so they put up a lot of fights about this name, and eventually they got it renamed to Uranus, because Uranus is one of the Greek gods, and so this fits the pattern of the planets being named after Greek and Roman gods. Now, what's really interesting about this planet, though, is it's actually tipped over on its side. And we're not 100% sure why this happened, but our best hypothesis is that something really big just ran into the planet and knocked it over. So yeah. All right, one last planet to go see, and that is the planet Neptune. So Neptune is the farthest of the planets. And we'll see it also has this really pretty blue color. That kind of bluish-green color of Uranus and the blue color of Neptune come from methane. Methane actually absorbs red light and reflects blue light. And so it's the blue light that bounces off the clouds and then makes it to our eyes, giving it that blue color. We also see that Neptune has a big storm, like Jupiter's. This one is the Great Dark Spot because, again, not clever with names. And it's very similar. It's another hurricane that we see, a big hurricane. This one's about the size of Earth, so not quite as big as Jupiter's Great Red Spot, but still a very big hurricane. The difference, though, is in recent years, we actually haven't seen this hurricane around. And so we don't know if it has gone away, or maybe there are some higher clouds that are covering it up. We're not sure. We need to keep watching to see if it comes back. Unfortunately, we don't know a lot about Uranus and Neptune because they're difficult for us to study from here on Earth because they're just so far away. And we've only had one spacecraft, Voyager 2, fly past them back in the late 1980s. And that's the only time we've sent a spacecraft to study them up close. And so there's still a lot that we don't know about these worlds. And so hopefully we'll get some new missions to go out and explore these as well, because we've paid a lot of attention to Jupiter and Saturn. But these guys out here have not gotten as much attention, and so we don't know as much. Now, I know that there's one more thing that most people want to go see. That is the dwarf planet Pluto. And I gotta say, I'm a sucker for Pluto. It's my favorite, so we're going to go see it. Pluto, as I just said, is a dwarf planet now. And so what happened in the early 2000s, we started finding more and more things that were like Pluto. Similar size, kind of in the same area. And so the question astronomers had to answer was, do we call all of these things that are like Pluto planets and end up with like 20 planets? Or do we come up with a new category for these things that are like Pluto? And that's what they decided to do. And that's where the dwarf planet category came from. Those are the things that are similar to Pluto. Pluto is the biggest of the dwarf planets, so he is the but there are 4 others out there: Haumea, Makemake, Ceres, and Eris. Now, what's most famous about Pluto, since we have sent a spacecraft to fly past, giving us our first close-up view of this world, is this heart that's on Pluto. It's just a fun little thing that we can see. All right, so we are going to make our way back home to Earth. And as we make our way back home, as I mentioned at the beginning of the stream, there are some activities that you can do at home to explore the kind of sizes of the planets and the distance between the planets. And so I'm going to tell you a little bit about those. And I have the activities links to instructions and information about them in the information for this video. But one of the ones that you can do is building Play-Doh models of the planets. And so there are instructions for how to roll out Play-Doh and cut it into certain pieces and which pieces go to which planet. And when you're done, you end up with Play-Doh models of the planets that are to scale for their size. And so you can see how big Jupiter really is compared to the Earth and how the other planets compare. And so it's a good, fun, hands-on way to really explore that. Now, the other activity that I have information for is to make your own pocket solar system, which lets you explore the distance between planets. Because a lot of times for us to really see the solar system, we have to kind of compress the orbits of the planets. And so in pictures of the solar system that we see, they often are a lot closer together than they actually are. And so this pocket solar system kind of helps explore how far apart the planets really are. Now, the instructions for the pocket solar system have you using strips of register or receipt paper. And I know that most people don't just have receipt paper lying around at home, but there's a way to do this with just a standard piece of like computer paper. And so all you need to do with your standard piece of paper, and it doesn't have to be computer paper, it can be notebook paper, construction paper, anything you want, but you're going to want to take it and fold it in half, hot dog style, and then fold it in half again, hot dog style. And so then when you unfold it, you'll then have these 4 creases that you can cut this paper into 4 long strips. And so you'll have these. And then all you need to do is take the strips and tape the short ends together. And that will give you something equivalent to a strip of receipt paper. And with that, you can then, oops, my camera's down here, make your pocket solar system and see just how far apart the planets really are and explore that. So those are a couple of fun things you can do. I also know that the Play-Doh solar system does require quite a bit of Play-Doh, and you may not have a lot or you may not have any. And so I've also included instructions for making Play-Doh at home, because there's a really easy way to make it with just flour and water. So I have those instructions as well. So I'm going to check comments. If anyone does have any questions, feel free to ask them now, and I will kind of tell you what's going to be coming up for our next few shows. And so Saturday, we've got a really fun show we're going to do, which is Star Wars Fact or Fiction. And so it's going to explore kind of what could possibly be real and true in the Star Wars universe and what is just pure science fiction. I think it's going to be really fun. It's actually a show that we are in the process of building for the Planetarium. And when we open back up, it's going to be one of the new shows that we're going to debut once we are open back. And so this is going to be kind of a little teaser for everyone to see what this new show is going to be like. I'm excited for it. My students have been very excited to work on it, and I think it's coming out really well. And then next week, we have on Wednesday, we're going to do another Ask an Astronomer segment. And so we'll have some topics that have kind of come up recently in astronomy news or interesting things that you can see in the sky. And we'll also take that time to answer whatever questions you may have. And then Saturday next week, we're going to do a show about exoplanets, planets around other stars. Kind of look a little bit into how we can find them, talk about what we have found so far, and also highlight some of the really interesting and strange planets that we have found out in the universe. So I'm not seeing any questions. So I guess we'll bring this to an end. Thank you everyone for joining us. As usual, any shows that you have missed or maybe you want to watch again, you can find on our YouTube page. But have a great rest of your day, and we'll see you on Saturday. Thanks, guys.